Hi everyone, my name is Milad and today I'll be doing a system design practice exercise. I'm doing these to help improve my skill set, but I hope in that process you guys learn something as well. Remember, always double check anything you see or hear in my videos. There are people far more talented in system design than I am. If you do enjoy the video, please consider liking this video, leaving a comment, and subscribing. With that said, let's dive right into the design. Today I'll be designing a file sharing system and I will try to satisfy the following requirements. Implement secure user authentication for identity verification, enable user to upload and download files with size limits, store files efficiently with data redundancy and backup, allow users to share files and set access permissions, keep log of file access for auditing. All right, so looking at this, we'll definitely be utilizing blob storage. Blob storage is where you save large binary objects like files, for example. You can save them in databases, but the best practice when it comes to files is to store them in blob storages. There are services like S3 from Amazon that allow you to fire these services up and have them operational really quickly. Additionally, because we have a lot of relationship between these many different entities, I'll be using a SQL database. In this particular example, I think Postgres would be ideal. We can also utilize MySQL. I don't think we will have really complex queries here, so maybe MySQL would be best suited. Other things we might utilize is for keep logs of file access, maybe a time series database or a NoSQL database like MongoDB. And we might definitely be utilizing CDN depending on the popularity of a specific file. And other than that, we can jump right into the database schema. That's somewhere I always like to start because it gives me an idea of what entities I am working with. Our first entity, user, we'll start off with user ID. And because we're using a SQL database, we'll be working with tables and columns. We'll have username, password, email, and status ID. Here we can have, as always, additional metadata that we deem appropriate, but for the sake of these exercises, this will be enough. Next, we will have user files. These are files that a user has uploaded. We will have user file ID, file name. We will have file type ID, letting us know what type of file this is. We'll hash the file so we'll know the hash value of that file, and I'll explain why that might be a good idea later on. Additionally, we can we definitely need size, and as always, metadata, that any additional metadata that we deem appropriate. Here we go, and date stamp, the date it was uploaded. We want to allow users to share these things, so let's do user file access. Here we will have user file access ID. We will have user file ID. We will have user ID, the user that is being granted access to this. We will have access type ID. That will be the type of access they will have to this file. And then we also want to keep track of who approved it in case there are multiple people who have access to this file and can share it. So shared by user ID, date stamp, and then a status ID. Also here we might, as always, additional metadata we want to hold. And now that I think about it, we are missing a really critical important here is the URL of where this file is saved. And let's take a look at this. Login, uploading files. permission. Okay, so here we definitely want to, here I'll just save the information into a NoSQL collection. We'll call it access log. And here we can have user ID, file ID, IP address, timestamp or whatever, etc. And any other metadata we want. All right. That's, oops, I didn't want to move this. Let's just make sure I get this. All right. All right, so let's start off. Because this service will be available across the globe, we, as always, start off with a global load balancer. And a global load balancer is designed to be the first point of contact for your request, and based on where you're located, it will direct you to the most appropriate region. And sometimes regions are down, so it will direct you to the next appropriate region. Once you are past the global load balancer, you're going to hit a regional load balancer here, and that regional load balancer will now direct you to a data center. And based on that data center, based on the algorithm you decide, it will choose the appropriate data center. Now you could do round robin, you can do least load, lowest latency, or weighted round robin. One of the reasons you would do weighted round robin is if there is discrepancy in terms of capacity and power for different data centers, you might direct more requests to one data center and less to others. Once again, depending on how those data centers are configured. Once you arrive to your data center, you're going to hit an API gateway. API gateway. Now, you could possibly also have a local load balancer here, depending on how that's structured, but for the sake of this specific region, this specific design, I'm comfortable with just hitting the API gateway. All right, so that is the beginning of our system design. Next, we will consider what we want to start off with. So here, why don't we start off with user login. Oh, actually, I just realized we forgot to do our API. So let's jump in right into the API here. So we will definitely have a post API signup. Here the parameters will be username, password, and email. You will get back either get back a user ID or error message. We'll have another post, API login. Here we will provide user name, password. I mean, you could use email as well. And you will get back a user ID or error. Next, we will have a post API. Let's do file upload, and we will have a list of one or more files, file data. And let's see, we will then here we will need our access token in the header. which is used to authenticate the user. We will have a post API file share. And for parameters, we will have a user ID. We will actually, let's do a list of user IDs, meaning you can select one or more users at one time. And then here we will have access type ID. Do we have that? Yes, access type ID. And our response will be success or an error message. Here, when we upload the file, we will get success. We will get link or links, depending on where the file went, or error message. Okay, that does that. We've shared it. What else? Upload, share. Next we need get API. We will get file list. Here we will provide, here we don't need parameters because we'll be using the access token, but we can have one or more filters here. And sort by as well. Actually, since we're doing a list, we need offset as well. And then over here in the header, we will have the access token. And the response will be a list of files with their data. Next, we want to do get API file download, and we will have file user file ID header, and we will have once again access token, and response will be a file or files. All right, next we want to do get API file link, and this we will have, really we don't need any parameters here. Our parameters will be empty, and then we will response will either be file or an error message. All right, those are our APIs. Obviously you can have many more here. I mean, this just satisfies the requirements that we have. So first thing first is let's do a sign up here. So we get a request. That request goes through the global load balancer, hits the regional load balancer, hits the API gateway, and then hits the user service. The user service here registers, and we got a MySQL DB server setup, we will have user data, file data, access data in our database. We will check the database to make sure that user name and email doesn't exist. And then send a response back to the client, letting them know the outcome of that request. Next, we log in. So we're going to hit our authentication server. Oops, where are we? We will hit our auth service. It will check that user information and the user service will then hit a cache. Now cache is utilized to have quick access to data that would otherwise be accessed through a database or temporary data. And when you're utilizing cache, what you're doing is saving data in memory, and memory is much faster than reading from a hard drive. So a common cache server is Redis. Let's go here. And in this Redis server, we will have user data to start off with. So user service will hit the cache and look for that user. If it doesn't find it, it will then check the database to see if it exists, and it'll return that information back to the authentication service. And if it all looks well, the authentication service will return an access token. Oops. Okay, next let's go to get our list. All right, so we will have a file service. I'm not being consistent with my capitalization, but let's be consistent here. All right, so what will happen is we get a get command. The request will be routed to the gateway. We will authenticate the user using the access token. If all looks well, we will then direct the request to the file service. The file service will then get the list of files from the user, look up get the file. So in addition to user data, we have file data as well. It will get all the files that the user has uploaded. If it doesn't find them, it will then look in the database. Next, let's do what we need to do. Let's do upload. All right, so we are uploading a file. So first, the request goes to an authentication service. We verify once again that the user is authorized. We then take the files and immediately save them into blob storage. This is a temporary location. In addition to that, we will wait for, once the file has finished successfully uploading, we then save the information of that file. We call the file service and save that information. In addition to that, we have a message queue. A message queue is where you send messages for other services that will be listening to it, so that when there's a message, they know that there is an action that they need to take. A common messaging queue service, Kafka, allows you to generate many topics, and each topic has a specific intent or purpose. So here we will have a topic called new file. And when it comes to Kafka, what you have are publishers that write messages to these topics, and then you've got subscribers, services that are interested in those new messages. And when they see a new message, they read that new message and then perform an action here. So we will write to this Kafka topic. And then what we will have is a service called new file processing service. Once again. File processing service. All right. Now this is a subscriber that subscribes to this topic. And when it determines that there's a new file, it will now perform many actions, and it really depends on what you want to do in terms of your business plan, but we'll keep it really simple here. So we'll hash the data, we'll hash that file, we'll save the hash information, and then we'll save it into long-term storage. And once again, we have a blob storage here. Long term, it will save that information to this new long-term location. It will then update the file with the latest information, with the new URL, and then depending on the popularity of the file. Save it to a CDN. And all right. So now we have a new location, we have the hash value, and we've updated the file information. Next, we want to get the file. So when we do a get, we immediately hit the CDN. If it's not saved in the CDN, what it will do is the CDN will so the request will hang on. This one, if we find that the file has not been accessed, the file has not been cached, the CDN will then make a request to the server to get that cache information, to get the file URL, the file data. So the request will go through the normal entry point, hit the file service. The file service will grab that data and then pass that back to the CDN, and the CDN will then cache that file and make it accessible. The CDN will verify that the user has access to the access token. All right, so that is our get. And then this is where we're downloading it. Next, we want to share. Okay, so now we're going to be sharing service. And here, let's just say we have a share service. Once again, when the request comes in, we authorize that we authenticate the user using the access token. We then send a request to the share service. The share service will then call the file service and verify that the user has access. The file service will look in the cache for that information. It will then verify that those users exist by communicating with the user service. And then finally, when it confirms both the access and the users that the user is trying to share the information with, it will update the database and update the cache as well. So now our cache also has share information, access information. Let's rename this to access service for consistency. Okay. And same thing when we want to get a link, when we're accessing a file through a link, that link is signed. The CDN can verify that that link is valid. Once again, if it's not cached, grab the information from the origin server. And let's see, we've done download, we've done file through link, we've got list, we've got share, we've got upload, login, and post. Sign up. All right, looks like that we have everything here. A couple of tables here that I should include would be access type, which would have access type ID, name, and then any other metadata, maybe function, or what you can do is just have other metadata that you want, and then access type function, and this would be access type function ID, access type ID, and this will let you know what functions are available to this user. Access, maybe we just have a function ID, and this is for more complex where you actually go in and edit, comment, and stuff like that. It's not necessary, but that's the way you would go. And then obviously we have a file type ID, name, maybe extension or whatever else you want. As always, metadata you deem appropriate for your service and business. Okay, let's see. And I think that is pretty much it. When it comes to scalability, here really it comes down to having an elastic infrastructure. Our Redis servers would be in clusters. That means that we could scale, have redundancy here as we need it. Our S3 buckets here, for example, our blob storage would have duplication, redundancy, and multiple data centers. We would also have MySQL clusters, and we would do consistent hashing to know where that data should live. Whenever you do any sort of sharding in a database, one thing you want to try to do is have related data be saved in the same location and the same shard. Otherwise, querying, especially when you have relationships, becomes really difficult. So that's something you should be mindful when you're thinking about how do you shard that specific, how you shard it, and what data, on what key you shard on. Same thing when it comes to Redis, when you want to partition that information. And then when it comes to scalability, have your system built on top of an elastic infrastructure like K8, where the services themselves will automatically scale based on configuration that focuses on specific metrics, whether it's CPU usage, latency, memory usage, or whatnot. And then obviously your load balancers will also help ensure that if one particular region or data center is down, it is directed to a different location. All right, and then the last thing we need, one last thing is whenever a file is accessed, we have our access log here, saved in MongoDB, and each time a file is accessed, we simply save that into our access log. All right, guys, that is all I can think of right now. I might have missed something, so this is why it's really important you guys help me by commenting. I hope you enjoyed the video. Once again, if you did like the video, please consider liking this video, leaving a comment, and subscribing. Until next time, have a wonderful day. Goodbye.